are in the Materials and Electrical Components Laboratory. We are part of the Product Assurance and Safety Department, and we predominantly support our space projects. I am the head of the Component Space Evaluation and Radiation Effects section, and in my section we deal with radiation effects on EEE components, electronic components. So we basically test the electronic components to make sure that they are suitable for flight in our spacecraft. The space environment is a harsh environment, and one of the components of the space environment is high energy particle radiation. These particles can adversely affect these components, and in the worst case, we may have a catastrophic failure of a component due to this radiation. So we have to know how the components that we're flying behave under such environment, and that is what we are doing in our laboratory. We are simulating the radiation environment that we see in space. Before we start an irradiation test campaign, we first have to generate a test plan. What we do is we set up a radiation experiment. We have produced the boards and the various measuring equipment that needs to be used during the tests. And we will install this in the radiation cell itself. In the control room, we will initiate the radiation exposure, and that means that we will raise the radioactive source so that the components that are placed in the radiation cell are exposed to this radiation, which is in this case gamma radiation. Gamma radiation is highly penetrating, so it will penetrate our components, and that is what we want because we are simulating the high energy particles that we have in space. And during the testing, we will typically perform several electrical parameter measurements to identify the drift that the component have with increasing radiation levels. And at the end of the test, we can say whether the component is working well for the environment that is supposed to be flying in, or whether the component do not meet our requirements. The nature of the division that I'm working in is to support most European Space Agency missions. Currently we are working on a mission to Jupiter, which is called JUICE, where the radiation environment is much harsher than what we see at Earth. So it is much more challenging because the components that you have to fly, they have to be able to handle much more radiation than we normally deal with. At the end of the day, the work we do is to help Europe be in the forefront of science and technology related to space applications.